On behalf of Web Edge Solutions, I would like to welcome you to our today's webinar, Architecture of Modern Applications. My name is Mikhail. I'm the Director of Curriculum Architecture at Web Edge Solutions, a company based in Toronto providing a broad spectrum of regular and customized training classes in a variety of fields. So the agenda for today, we will touch upon problems with monolithic applications. We'll also try to kind of do this post-mortem, why SOA failed. Then we will segue to microservices architecture. And we perform some contrasting between the traditional architecture with modern. Again, modern applications, it's an extremely huge topic, and we cannot claim that we would definitely find that blueprint for the next big thing, but at least we will touch on those points that will make the picture clear. And as long as we understand what the problem is and what possible solution could be, it's already would be time worth spending. The monolithic applications essentially are not going to just be gone, and they have their own specialized use cases, and we still need to consider a monolithic or monolith application in all those areas where we need high performance kind of real-time scenarios. We need to take into account some complex transactional processing that happens within the runtime, and we would definitely prefer to have everything happening in one image deployed as an executable or in a virtual machine that can do the job, maybe just one single job, as fast as possible. Sometimes we are driven towards this monolithic architecture or design of our applications because of security and the high cost of cross-process interaction. While it sounds extremely kind of enticing, appealing to make those calls across the globe over TCP/IP or HTTP channel, but there are costs, and sometimes they are something that we cannot afford. And we know that monolithic applications are deployed as a single archive, and those archives, whether it's Java or .NET, they might become pretty big. So disadvantages of monolithic applications, I don't want to preach to the converted if you have already kind of seen that, and most of us have this kind of a fair share of this abuse. So we know large code base, so you deploy everything as just one big file like ER or WAR file, and whenever deployment fails, particularly when it happens at 3 a.m. in the morning over the weekend, essentially you're doomed. You have to sort out the problem over the weekend, lots of pressure. And that large footprint is one of the, I guess, complaints that people have. Tight coupling makes it difficult to evolve subsystems. You need to really deploy everything as a single code base in one deployment bundle, and evolving is extremely difficult. So essentially, there is a resistance in the architecture of your application. Testing, in order to test certain systems, while you can always factor out certain components and do that kind of a test-driven development, but generally testing the whole thing during the system integration tests, like SIT tests, it becomes a problem. There is always some side effects of some system kind of leaning too heavily on others, because of, usually the problem results from the fact that we deploy our application, maybe potentially several WAR files on an application server, and the same heap, Java heap process, for example, Java or .NET, is being used by many applications, and any rogue application because of the runaway thread or any other problems that might occur would bring down the whole system, affecting applications across the board. Difficult to scale. Of course, you can create a cluster of machines and deploy that bundle across all the machines, but then essentially deployment, because of the large deployment bundle, becomes a problem. You need to synchronize, and usually deployment, if you have been involved with that, like several megabytes worth of deployment on non-application server might take like several minutes, right? Particularly if you enable some just-in-time, just compilation of some of the dynamic resources, and it might be a problem during the deployment, but scalability is also a factor because you need to share the state. It can be a database, and then database becomes a bottleneck. You can start passing messages using some sort of asynchronous communication. So it's difficult to scale generally, and you might become locked in to a particular vendor, whether it's kind of a big name, 3 letters or more than that. And that vendor would be offering you solutions as long as you have deep pockets to pay for those solutions, right? So essentially, everything would be revolving around that vendor. And we've been in this field, and we know that lots of those kind of challenges, problems can be addressed by a number of decisions like employing layered architecture, using aspect-oriented programming to do orthogonal design so that we create cross-cutting concerns like logging, security, what's not. Low coupling, designed by contract, where essentially your monolithic application is built such that you've got some sort of XSD schema that allows your one layer to communicate with another. Dependency injection, originally, I guess, driven by Spring, and now part of all, I guess, major versions of enterprise systems like JE, Java Enterprise editions since version 5. Dependency injection is part of the normal business. So that helps you with to a certain degree, not very much. By the way, I didn't mention that. If you have any questions, don't hesitate to put your question in the questions pane. You should use that. I wouldn't be checking anything else. And if I feel that time is good for answering it, I'll take it on right away. Or we will have a Q&A session at the end with the presentation. Presentation is scheduled for about 1 hour. We can finish early. It depends on how we go. So, one of the kind of a way to address those problems just across the board is to start breaking up the monolith and creating kind of a services using some sort of a service-oriented architecture of some kind, where you would bundle that functionality as per particular domain running on a specific, deployed and running on a specific service. So now we can start thinking in terms of ensuring scalability at a service layer, right? So we can, if we know that a particular subsystem, not the whole system, but just one specific subsystem is critical for the health of the whole system, we can definitely improve scalability at that layer, at this kind of a level, at this service. So we essentially dramatically increase the resiliency to failure for the whole application. So our application would be pretty much some sort of a front to a fleet of those services running, servicing and working towards a common goal. So we would have smaller services, and we can achieve a better evolution of those services as long as we use those traditional techniques like contract-based interaction between services. We can achieve better testability because services become more narrow. They become more isolated, doing just one job very well, and we can test them in isolation. So we can stub certain services for backend, and we can simulate user interaction, like clients to that service in a number of ways. So we now in the area where we can pretty much be driven by domain-driven design, right? So Evans's work would be well be used here. Dev teams would become smaller. We would have something called two pizza box team, and small teams where you probably have business analysts, maybe testers assigned to that service. So essentially it would be a small, very efficient, nimble, agile team working and getting all the rewards for doing a good job, or getting all the flack doing a bad job. You can achieve a product-oriented dev model where a particular business capability is broken up in several services, and every service is essentially built as a product. So you become responsible, that two pizza team would become owner of that particular product service, and they would be responsible for the full cycle of the application. So cradle to grave cycle, any problems rolling out, rolling back, any failed deployments, performance tuning, and what's not. And you would probably have someone from your team carrying that 24/7 production pager. But at least you would be responsible for that particular thing. Well, of course, if you've got multiple services, lots of teams, and you've got a problem interconnecting, orchestrating that fleet of services, then definitely all the people would be on board, all hands on board. And the Internet of Things is becoming, or IoT is becoming a reality, because now you can essentially reach a level of granularity to the level where there would be probably just some sort of a Raspberry based appliance servicing certain things. So that's kind of a generic, I guess, trend. So what happened with SOA? And we understand that SOA had been all the rage several years ago, and somehow people have become kind of embarrassed to mention SOA as a style of architecture. But there was nothing wrong with the SOA as that mission. It's kind of a, sort of like this communist manifesto, right? Nothing wrong with that. It's just everything's fantastic. But I guess implementation might be kind of out of whack. So us are the problems. So I guess if you want to point a finger, just bend it and point it to yourself. And I guess that would be probably a way to move ahead after that. So in most cases, what we did, we got web services using XML as a payload. I guess that's simple. Was a little bit of a red herring. It was a little bit of I would say one of those hype things that essentially get people on board, and then showing all the complexities that come with that simple object access protocol. Right, but I guess, and we witnessed a number of specs around SOA, such as UDDI and all those WAS star specs with reliable messaging, transactions, security, and what's not. Some of those are extremely useful and extremely reliable and implemented in production, but they came with some sort of a complexity, and that complexity was unavoidable. It was kind of one of those things that just come with the territory. So an application server, And that was, I guess, one of the driving forces that really got people on hook and made them kind of paying through their nose. Application server became kind of a centerpiece of the whole thing, creating dynamic content, providing all the services, kind of a battleship of that kind of a frontier. And lots of consulting services were around this thing, and the consultants, you know, they always tend to overcomplicate things so that they make themselves indispensable. And they write books, and those books just sound very scientific, but if you really dissect the WSDL, WSDL file, it's nothing more. It's just guys from Microsoft and IBM just trying to show who is smarter, and eventually bringing to life something that is kind of useful, but a little bit over-engineered. For example, UDDI is something that is a good example of what might have gone wrong. So huge spec. Dr. House would probably throw it at them, saying something not very pleasant. Inquiry publication, all those fine get. Immediately you see that those probably were SOAP requests rather than getting using REST for the API. Maybe you can survive it. And those small t for the templates. It's kind of a totally bizarre spec, but it's just one of the examples, kind of a poster child in a negative sense, if you will. So next generation applications. So we've become, I guess, we've been through that. We've got our fair share of, I guess, bumps and scars. And now things are just quite rapidly changing in the world of the modern IT. And it's not only in the technology, but it's also in the realm of methodologies, tools, new approaches, not only just designing applications, but deploying, managing, and running them. So we've got cloud, we've got DevOps practices, we've got lots of things like container-based deployment of applications. So in many cases, you need not only learn new things, and they pretty much, I guess, just evolution. I would say maybe in certain areas it's just a revolutionary approach, but you need always to take it with a salt of grain. And in many cases, you need to reevaluate your knowledge. Just maybe unthink. It's difficult, but sometimes unthinking helps you to kind of liberate yourself from those dictate of previous misconceptions. So Web 2.0 is kind of a big term. It's been around for quite a long time. Maybe people start thinking about Web 3.0 or something. But essentially, we are talking about more active, more rich and dynamic content being generated on the internet. So we've got kind of a client becoming richer, which might become responsible for generating content, dynamic content, and maybe performing some of the tasks that haven't been previously possible. Maybe performing client-side encryption, maybe persisting some data using a web store on the client side. So this is in contrast with the traditional or old Web 1.0, where we had kind of a static web page content where application servers, those, I guess, monolithic, huge things would use some sort of a technology, SPX, JSP, GSP, GSF, or PHP, what's not, to generate the content that will be sent to the client, to very smart and extremely powerful internet-aware agents as kind of a pre-built XML with very little, I guess, dynamism. Maybe just some sort of a form evaluation JavaScript and some sort of a basic, very rudimentary functionality. But now things are changing, and the focus, I guess, that kind of overall attention is moving towards the client. So we are now talking about the rich internet client applications. So, and everything is driven by smart agents, browsers, because that's what's becoming the de facto client. right? So people used to have some sort of maybe applets using Java applets, or maybe Java applications on some other executable modules, but essentially they are, I guess, no longer appealing to lots of people. So JavaScript essentially a language, probably one of the most popular languages in the world. JavaScript gets executed in a virtual machine in the browser, attached to the browser, and essentially you can do lots of things, not only on the client, but now things are moving towards the server. Like with Node.js, you now have server-side JavaScript. Right, as long as you break that sandbox and you get access to the low-level primitives like input-output, networking, and essentially you can create everything outside this sandbox, which is used by browsers when running JavaScript. Right, and there is fewer and fewer differences between implementations of JavaScript. Before, there used to be problems, not so much between JavaScript editions, ECMAScript implementations, but more generically different ways of treating DOM, document object model, that graph of your backing up your page, your HTML. Right now, that language stack is becoming more tightly implemented across browsers, Opera, Mozilla, and you name the others. Okay, so we've got computers which are now running on 64-bit multi-core CPU architectures with plenty of RAM. Kind of a minimum, I guess, is becoming 8 now. So essentially, why not make that guy do the fair share of work? Not kind of make the server kind of busy servicing all those hundreds, maybe potentially thousands of concurrent clients. Let's push out some of the work, kind of download, make them work, and they would be happy to crunch and help out, right? And so development, those kind of recent developments are essentially moving towards rich internet applications, so RIA, rich client application, or fat client, if you will. Fat client would probably be not a very politically correct way to name it, but I guess rich client. Okay, so we'll you can play on that kind of a rich client, poor application server. So we've got clients now performing a lot of having lots of responsibilities that were previously done by the application server. So you can generate dynamic content just by making an AJAX call, pulling out the data, or maybe WebSocket kind of a call to the application server, or web server, kind of it would probably become more appropriate to name it like that. Pull out that payload, usually in the form of text file or JSON encoded document, deserialize it, or maybe use it in to dynamically generate the content. So everything is available now on the kits, frameworks for the client side applications like MVC type of applications. So essentially all those applications that have been servicing us in the past are becoming less and less loaded, so to speak, right? So you are moving towards that new paradigm where we've got rich client and thin server, right, or poor server. Right, so rich client essentially has lots of smarts. Definitely it shouldn't contain those sensitive information that you can kind of move around, maybe some sort of security keys like symmetric keys or what's not, but essentially any dynamic generation of the content can be done on the client side. Right, and the calls between AJAX and WebSockets, the main differentiating factor is that WebSockets are not restricted by the same origin JavaScript policy, right? So essentially, you can have a much more kind of across the board type of applications. In case of AJAX, you would need some sort of a proxy, where the proxy would be receiving requests and the reverse proxy would be dispatching calls to the backend services, and then kind of aggregating calls and sending back. So that JavaScript would essentially be servicing the front service. And the thin server or poor server would be just fronted by a bunch of RESTful endpoints where things would be done using the CRUD type of HTTP semantics, create, read, update, delete, because HTTP spec supports all of those. You can do patch as well. And now the server functionality, that's kind of a monolithic application. So that's where I guess things becoming the point of kind of a breakup. So we've got multiple services which essentially take that specific portion of functionality, probably orthogonal to other services, and externalized in an external service. And it becomes a product, and you've got that two pizza folks working on that service. And we're talking about the microservice-oriented architecture. Microservice is not so much about the number of lines of code that you can deploy, but micro is just a way to highlight the point that we are talking about services which are nimble, which can go all the way down to just a very basic HTTP listener doing just one job. But potentially it might be some sort of just hard-coded device with hard-coded logic. Microservice is a little bit of a misnomer, but I guess we always suffer linguistically to give a proper name. So we kind of are moving towards a situation where servers' responsibilities are becoming much less prominent. We've got traditional, maybe validation, maybe security type of checks and logging and what's not, the traditional responsibilities of a web server, integrating with the backend, but we essentially extract the dynamic content generation and push it out to the client, to browsers, right? We offload a great deal of responsibility, and we make our applications much smaller, easy to deploy, and essentially more testable, and we achieve lots of good stuff. So the question is, just curious, and this may not be related, but with this rich client model, any personal information privacy issue for that browser user? I guess I mentioned that in passing, right? That security is definitely a concern. So the moment you start moving towards a rich client, you need to have that mental check. So, okay, guys, what can go and what should stay on the server, right? Again, the server is your bastion. It's your really your fortress. You've got kind of a security. You've got white zone, green zone, DMZ, and what's not. With client, whatever goes to the client, it's in open public domain, and you can always perform session hijacking, right? You essentially can, I guess, use some people's browser when the person just steps out from the desk, and a bad guy, I wouldn't give a name of that bad guy, would just step in and just perform kind of a quick page source review. So definitely you should kind of exercise your better judgment in that. Okay, but it's kind of a big topic. But definitely it's a pain. You cannot outsource everything, right? There should be some sort of triage, kind of a commission, just checking what should go and what should stay. So microservices, again, this term has been coined recently, and people just jumping on that bandwagon, trying to maybe start talking about a new thing. It's not a new thing. Essentially, it's SOA under disguise, but probably more, it's kind of a more technology-aware SOA, where you've got a number of practical things that come with that term, right? So you can achieve all those things through partitioning, and you are trying to achieve faster development, versioning, better testing of those services, right? And now microservices have a very good marriage with deployment modalities, such as lightweight virtual machines, right? It may be a Linux container, so it can be Docker, or it can be, I don't know, PaaS, platform as a service, what's not. And microservice is being accessed through the API. All that stuff is just SOA. But the moment you start going with, I guess, RESTful services, lots of benefits of SOAP, like WSDL file, schema, is kind of going away. You're just foregoing all those benefits, right? So I guess there should be some sort of a balance. If your payload is XML, then apply schema for validation. XML is also kind of a way for hackers to build a vector attack, so that XML schema kind of a mess up can become a reality. Microservices coordinate, they have smarts. So those smarts are essentially deal with request routing, data format negotiations. Do you want to do, I don't know, just a text file processing, or it would be an image? Those of you have been involved with SOAP with attachment. It's just one of those kind of a good thing about SOAP, but it was just very kind of a cumbersome to implement right. In case of REST, it can be just specifying the type of the payload and just having the payload. It can be image, 64-bit encoded, or any other formats that you can negotiate smartly between clients. And microservices have embedded business logic, right? So lots of those things were taken on by, that responsibility roles were taken by enterprise service bus implementations platforms, ESBs. But microservices now kind of take this and they just distantiate themselves from ESB or any monolithic applications for that matter. So microservices can be, I guess, visualized by using that command line pipe mechanism, where you can essentially take the system out from the previous command and send it to the system in channel of the next command in the pipe. So that's how you can build very sophisticated processing pipelines. Okay, so microservices are those standalone tools like word count, grep, sed, and what's not. Just doing just one job and doing it right. Microservices architecture is essentially a nice way to refer to a new style. And again, pretty much it's SOA. It's the same architecture style, but it has lots of not so much architectural style type of aspects, but it's more about technical implementation, where you've got deployment, kind of protocol, smarts, and it's kind of microservices probably it's a SOA done right. Okay, so I guess I'm not going to read the whole slide. If you're interested, you can go back. Interconnectivity is important, and so before that, I guess SOA used just XML over HTTP, and microservices, I guess, also profess the same religion. HTTP is a transport of choice, but in many cases we're moving towards REST, and what's more important, things are moving towards interoperable solutions using the payload. So the payload can be encoded in a specific format, Avro, protocol buffers, just JSON, plain vanilla, right? And it's easy to I guess, negotiate the payload, and you can create interoperable solutions between, so that your microservice can be implemented in your microservices in your architecture can be implemented using a number of languages like Python, Scala, you name it, as long as they have clients for that particular interoperable data encoding format for that RPC type of communication. Okay, so in addition to the synchronous communication like RPC, we also can see a number of lightweight messaging systems such as RabbitMQ. What we're doing here, we agree on the wire level protocol, so that as long as a particular programming language has a driver or has that RPC library for managing that wire level protocol, where all the octets are properly aligned with the header, payload, and checksum and what's not, you can essentially create interoperable solutions. And you can get people maybe from another company who have history in using C#, right? And you are Java shop, right? No problem. You just agree on those wire level protocols, whether it's RESTful, RabbitMQ, essentially MQP implementations. You can do messaging, right? And so non-blocking remote calls are also popular, like Ajax has been around for quite a long time. WebSockets, now HTML5 has it as a spec, and most modern application servers or web servers implement WebSocket. So WebSocket, it's a new way to kind of a new frontier altogether for us to build interactive, highly reactive applications. So I mentioned that Interop considerations don't discard XML. It's still kind of a viable thing, but XML would probably be the last thing you should consider, right? So implementing microservices, I guess that's where things really become not so much architecture as it becomes not so much design as it becomes really software design. In many cases, many application frameworks move towards implementing that in kind of inversion of control, where you've got an embedded HTTP web server. I'm talking about Java, for example. They have Tomcat, Jetty, Undertow. So essentially what happens is that you've got regular Java applications that you run as a standalone application, which has a main method public static void main, which essentially instantiate an HTTP server, which is embedded, and that HTTP server essentially exposes an endpoint for the IP address and a particular. So the IP address would be of that machine on which you run it, and the port is configurable. And within, I guess, several seconds, you would have an application. And all your logic is built around that endpoint. You can also embed databases. Java is extremely versatile in this field. So you've got a whole bunch of Java-based databases. One of those databases is bundled with the Java DB. Apache Derby is part of the Java distribution for quite a long time. It's quite capable, by the way. Microservice can always leverage that embedded endpoint for HTTP and embedded database. Of course, if something goes wrong, the whole thing would be out of the water. But I guess microservice can be, I guess, made resilient through some scalability mechanisms. It's quite easy to do. Okay, so. It's kind of a popular mechanism for probably web type of applications, maybe still be not acceptable for enterprise grade of applications, right? People would just, I don't know, be reluctant to adopt kind of a database at the application level. People would start talking about maybe Oracle, I don't know, DB2. Something like that, but it's just one of the ways to maybe maintain state. If you have a kind of a fault-tolerant application and you know that something might go wrong, you just maintain the state of the previous command, and when you restart it, when the problem just gets resolved, you can always pick up the state and just continue as if nothing has happened. So it's quite, I guess, prevalent in those preemptive virtual machines where you've got something running in the cloud, where you buy very cheap instances on Amazon or Google Cloud Platform, and you need to maintain the state between calls because you would have that lenient kind of a leniency period within maybe 1 minute 30 seconds. You'll get a notification that you are going to be shut down and preempted. So essentially you can preserve, persist the state of your application on that store. Okay, implementing microservices, Spring Boot, Drop Wizard, which essentially Drop Wizard probably was a showcase, and Spring Boot just took after Drop Wizard solution. Right, Node.js is becoming a very popular platform for building and running microservices. Mind you that crossing boundaries is expensive. When the moment you start talking about RESTful endpoints, immediately think about that you've got your application that you originally broke up and you had kind of a millisecond type of access and processing. You would probably have to think about maybe 10 times more, maybe 100 times or more, even more. Right, this cross-bound kind of a boundary process becomes an issue, right? And you are losing maybe security, maintainability, manageability, and other quality of service of your architecture. Managing microservices, that's where, again, it's not so much about our microservices architecture. We're talking about technical details. And microservices lend themselves to all those interesting things, such as container orchestration solutions using Docker, Kubernetes, and what's not. Maybe even Linux, just raw Linux containers, which is lightweight virtualization built in the kernel of modern Linux systems. I guess Microsoft is also offering similar solutions. Okay, so you need to kind of think about controlling the life cycle, have a centralized configuration management, and in some cases there are solutions available, like Netflix is offering SSOs, kind of OSS, open source software for doing that. You can use Zookeeper, Apache Zookeeper, a Java-based solution for managing resources across your cluster of machines. Okay, so it's multifaceted activity, for sure. Design for failure is definitely something that you should start thinking about because the moment you adopt this model of microservices running on a cluster of machines, failure might become kind of a big problem. So you need to cope with that, and you have to be prepared. So one of the design decisions that you should make early in the game during your design, stateless design of your applications, a state, if it's needed, should be externalized, right? Persisted somewhere. Right, caching is very important. Load balancing, redundant instances. So that's the common, I guess, technique. You've got round robin or maybe less used resources type of load balancing. And it helps you to cope with spikes in user activities, right? And capacity planning is kind of gives you a peace of mind. Essentially, you have some redundancy, some slack, which can be utilized when, I guess, the crunch time comes. Autoscaling can be, or possibly can be put in place. Elastic means that it can kind of work in both directions. You can scale out and you can scale in. Scalability is mostly horizontal, not so much about vertical. That is prevalent in monolithic applications. Fault injection, Netflix, Simian Army is one of the way to look at it. Chaos Monkey essentially just tries to sabotage your system by just deliberately shutting down some of the instances, and kind of a fault injections is happening, but everything is happening in that kind of a pre-production type of environments where you have a way to really try to break your system. And you would be ascertaining the resiliency of your system, how well your system would cope with when you essentially push your system out in production, and all of a sudden, like, people would start pounding it with kind of some stupid, unformatted requests, and pretty much just taking a field day trying to really bring your application to the knees. So just be prepared. And I guess final two slides, I guess, would be worthwhile to discuss. So those two slides just show a traditional enterprise application architecture, and the next slide shows how that application could be refactored into microservices architecture. It's a little bit of a subjective thing, and I guess you can argue in many ways, but I guess my experience, I've been kind of working with both, and because I see lots of advantages of one over another and vice versa, right? So we've got, let me maybe highlight a couple of things here. So we've got thin client, right? Essentially, it just renders pre-built HTML, and HTML is built by application servers, which run stateful applications using one of the, let's say we are talking about Java application, enterprise application server, right? Expensive. Of course, you can use, I guess, JBoss or Wildfly. You can use Tomcat, but I guess big banks and insurance companies, they use, I guess, proven vendors, quote unquote. So we've got a web server, which we've got a cluster of web servers. We've got a cluster of application servers, and web servers, they've got responsibility for servicing static content, CSS, images, JS, and any request for dynamic content, you need to configure that plugin. That would essentially would be a module on that web Apache server or Nginx, sending the request to the application server, where that using the affinity cookie, that affinity cookie would essentially help you to route your request to that application. Right, if you want to share the state, you would need to have some sort of session sharing mechanism. Usually it's a HTTP session, which is part of the heap. And in some cases, some vendors offer you a solution based on some sort of a persistence store. It can be a database. And that database would contain the session in a serialized form. That HTTP session could be transparently serialized using some of the infrastructure code. And then you would essentially have a way to remove that affinity. So every application server would be able to serve that session to the client. Okay, so that's the standard thing. Very efficient for servicing content. Security is enforced, and backend connectors are usually configured in the application server connector. That's the way to keep you hooked. So when you want to kind of break from that game, they kind of take you, grab you, and just they drag you back into this game. You have to stay in this application server because the container gives you kind of a bunch of services like JMS connector, you've got database connector. You have to configure it through that console, and you need a consultant who would help you with that. Consultant, we offer this service at a discounted rate now, and the whole thing is going on and on and on. Nothing bad, as long as you have been using it for quite a long time and it has become part of your DNA. Essentially, there is no way to change your mentality because, as I guess, media is the message. Essentially, that's kind of a statement would be correct in this context. So moving on to the microservices example, again, it's just maybe subjective, not very kind of a right way to do, but at least it's just a way to contrast that previous slide with the new one. So what we have here, so again, let's do a little bit of kind of digging. So we've got some sort of a web server, maybe application server as well, but essentially it has a stateless microservices deployed. We can have a cluster fronted by a web server, which can be also acting as the reverse proxy. Right, and the application state should be externalized in some sort of cache. There is so many cache solutions out there, so it's just a shame not to use those, right? And application servers, application containers would still perform the traditional roles of request validation, maybe connectivity to backend, and responding to service requests. And we've got a rich client. So application essentially forgo and the external download all the dynamic content generation to the rich client, right? So the rich client would use some sort of a framework. It can be React JS, it can be Angular JS, or Ember, or whatever your choice might be. So essentially, you create single page applications, sort of a kind of a quote unquote, where you've got JavaScript acting as that kind of the ubiquitous programming language, which would make AJAX or WebSocket call back to the server, pull out the data payload in any of the supported formats that you want, and render it using any of those frameworks in the rich client, right? Essentially, you just offload extremely big part of the application server code. You can do scaling of those clusters of those applications quite easily, and it can be done on a per service basis. And you can still have the web servers servicing static content, but application servers, essentially, they are doing much kind of a lesser load of the traditional workload. Right, so that's pretty much it. I guess it can be expanded, but essentially that's the common way to architect your applications. It would take some time to really do the refactoring, and you should probably start doing it slowly, step by step, by kind of chipping off some of the services, maybe not essential for your application, and slowly moving them out of those monolithic containers, right? So you just identify a particular service, externalize it, and start moving towards that direction, and see so that it's not disruptive. So it's not really causing you any grievance down the road, and essentially you can, I guess, get yourself fired because you have undertaken a very dramatic and drastic approach. Okay, so that would be the last slide for us before I do our offerings. That's something that you can probably take a look at today. Quick introduction to microservices and showing some of the, I guess, modalities, facilities available for you. Okay, any questions? We will share webinar recordings. I believe so. Yes, Jaya. The webinar slide deck and the recording will be made available later on. It's not this day, probably not this week, maybe next week, depending on the load on our publishing service. So check with our website. There's like a section called previous webinars, and see if it has been published. So the question is, how do we track a state using microservices? Let me wind back. I would say I'm going to this slide. One way would be to have an embedded database or database dedicated to a particular service. It can be shared by those multiple instances of a service for scalability, or it can be a cache of some sort. So essentially, to maintain the state, you would probably be well off by using that specialized persistent store attached to your microservice, as opposed to kind of a generic database which would contain the state for all your applications. Because state is transient, it's volatile, right? A state is about just coping with some disruption of the service, right? And just maintaining the state machine of your interaction with the client. So I would say an attached, specialized, potentially embedded database of some sort. For example, if I have to implement a shopping cart, yeah, for shopping cart, I guess shopping cart is critical for auditing, for statistics, for validation. I guess it should be the common database, which would have probably not attributes of a relational database. It would probably be some sort of a NoSQL, maybe MongoDB, CouchDB. So for that, you would definitely need to have a specialized database which would be used across multiple services. So if you need a continuum between services, not something specific to a particular service call, to a particular service, right, for maybe testing or for auditing, if you need it just to complete a particular workflow, just going from kind of making an order and doing payment and essentially confirming the user details for the order. So you need some sort of a persistent store, and usually it's a NoSQL. So the question is, and have that shopping cart available through different channels? Yes, that's exactly what we are talking about, right? So you've got different channels, and you've got probably multiple services which work in concert together, right? You probably are passing some sort of a token so that you can stitch together all those calls. So you need to have some sort of persistent store visible to all those agents, but those players, actors participating in that flow. Okay, so I guess I don't see any more questions coming in. I would like to thank you for attending this webinar. Hopefully you find something useful. And again, everything is up to you how you want to deal with that. I guess I just want to wish you every success in your future endeavors. Okay, thank you. Bye-bye.